All right, today we're doing something really cool. We're cracking open the playbook for a data engineer working in the social justice space. Seriously, we're diving into a technical interview guide that lays out a whole philosophy for building powerful, ethical data systems that can actually change the world. Let's get into it.
This is the whole ballgame right here. It's the mission statement that frames everything else we're about to talk about. It's a complete shift in mindset. Look, the goal isn't just to write some clean code. It's about building entire systems that understand the weight of the data they're holding, especially when that data represents actual human lives.
So here's how we're going to break it down. First, we'll talk about what it means to be a new kind of engineer, building systems that are professional and reproducible. Then we'll get our hands dirty with the messy reality of civic data. After that, we'll see how to make all that data smart and super efficient. Then comes the crucial part, building a conscience into the system. And finally, we'll connect all this tech back to the real-world mission, actually influencing policy.
Okay, let's dive into Section 1. The whole point here is to get away from flimsy, one-off scripts and start building systems that are truly professional. And by professional, I mean they're reliable, they're auditable, and they're built to last.
You know this problem, right? It's the classic, well, it works on my machine. An analyst runs a script, gets a number, and that number goes into a report. But a year later, nobody, not even the person who wrote it, can get that exact same number again. In the world of policy and justice, that's not just a headache, that's a total failure of credibility.
So what's the solution?
It's a concept called event sourcing. Think of it like a system's perfect memory, or a living constitution. Instead of just saving the final answer, you save every single change, every single decision, as a permanent, unchangeable record. This creates a flawless, auditable history trail, which means a study you run today will give you the exact same results if you run it again 5 years from now. That's reproducibility.
Okay, but that's a totally fair question, right? Governments and nonprofits, they aren't running on the latest Silicon Valley tech stack. No way. They're running on ancient Access databases and these unbelievably complex Excel spreadsheets that are, absolutely essential to their daily work. You can't just go in and rip and replace. So, what do?
You build bridges, and this is such a smart, pragmatic way to handle it. You don't even try to fix the messy data inside the old system. Forget that. You just write a simple script to pull the raw data out and dump it into a modern environment, what we call a data lake. Once it's there, you can use all the powerful modern tools you want to clean it up and analyze it, all while the original system just keeps chugging along. It's all about modernizing without causing chaos. All right, on to Section 2, where we tackle the challenge of taming hostile data. And hostile is the right word. This is all about building systems that can survive in a world where your data sources are messy, they're unpredictable, and they're coming from all these fragmented old systems.
Oh man, every single data engineer has felt this pain deep in their soul. You've got this long-running job scraping data from some clunky website, and right before it finishes, it dies. Do you really have to start all over again, waste another 11 hours? The philosophy here is simple. You have to assume that failure is going to happen.
And the solution is this beautiful little strategy called Lake First. It's so elegant. You completely separate the act of getting the data from the act of understanding it. The scraper has one job and one job only. Grab the raw file, the HTML page, the PDF, whatever, and immediately save it somewhere safe. Then, if your complex parsing code crashes later, who cares? The raw data is safe and sound. You just restart the parsing step, which is cheap. You never have to go back and do that expensive, time-consuming scrape again.
And this also brings up a really important ethical point. When you're pulling data from government websites, you are using a shared, often underfunded public resource. A polite robot is designed to be a good server citizen. It uses rate limiters so it's not hammering the server with requests, and if it senses the server is struggling, it uses something called exponential backoff to literally back off and give it a break. The goal is to get the data you need without, knocking the whole system offline for everybody else.
Okay, Section 3, building an intelligent engine. So we've gathered all our data safely, we've done it ethically, now what? How do we turn this massive pile of raw files into something that gives us fast, usable, and automated insights?
Well, first you have to deal with this. This is one of the thorniest problems in civic data, period. You have records from the jail, the courts, state agencies, and they all refer to people in slightly different ways. Is John Smith at the Tulsa jail the same person as Jay Smith at the Rogers County Court?
If you can't get that right, you can't even get a basic accurate count of how many individuals are in your system.
So this is where you have to get way more sophisticated than just matching text. You need advanced techniques like probabilistic record linkage. This involves using things like graph databases to map out relationships and AI models to find similarities that go way beyond simple spelling. It lets the system say with a really high degree of confidence, yes, these two different-looking records are in fact the same person, and that is absolutely vital for any accurate analysis.
Now, let's talk about money, because nonprofits and public agencies do not have a blank check for cloud services. So how do you build a system that's powerful but doesn't bankrupt the organization? The number one guiding principle should be this: if a process isn't running, its cost should be zero.
And here are the key strategies to make that happen. First, you use what's called serverless technology, which scales to zero. That literally means you only pay for compute power the exact moment you're using it. Second, you use tiered intelligence. Use the cheap, fast AI models for 99% of the bulk work and only bring out the big, expensive, powerful models for the really tricky stuff. And finally, you build in circuit breakers, automatic safety switches that will kill any process that runs for too long or starts costing too much, which prevents those horrifying, budget-destroying accidents.
All right, let's shift gears to what might just be the most important section of them all, the system's conscience. This is about building systems that are not just powerful, but are responsible and ethical from their very first line of code.
Check out this ethical pretzel. It's a perfect example. Someone gets their criminal record legally expunged. You have a legal and ethical duty to honor their privacy. But if you just hit delete on that record in your database, you've just corrupted your historical data. Your trend analysis is now wrong. So what on earth do you do?
And the solution is this really elegant idea called tombstoning. You don't actually delete the data. Instead, you perform a logical deletion. You basically mark the record in a way that makes it cryptographically sealed off, completely inaccessible to any analysis or any user. It's still technically there, so your historical logs are accurate, but for all practical purposes, it's a ghost. It's gone. This is the perfect way to balance the need for privacy with the need for accurate history.
I mean, what a powerful statement. This means you don't just write a privacy policy, stick it in a PDF somewhere, and just hope people follow the rules. No, you build privacy directly into the architecture of the system itself. You use tools like role-based access control to make sure, at the database level, that a researcher can only see the data they are authorized to see, and not one byte more. The rules aren't a suggestion, they are enforced by the code.
And that brings us to our final section, from code to policy. Because all this incredible technology, all these clever solutions, they're completely useless if they can't be translated into real-world impact. This is all about closing the gap between the engineers and the policy experts.
So how do you take a huge kind of vague goal like measure recidivism and turn it into something a computer can actually execute? The answer is a communication framework called the Oracle method. The engineer's job here is to act as a translator. They listen to the big goal, and then they ask a whole series of clarifying questions to break that big idea down into tiny, concrete, well-defined tasks. It's a process for turning fuzzy policy ambiguity into a rock-solid, testable engineering plan.
And this right here ties it all together. This is the ultimate why behind everything. Every single technical decision we've just discussed, from event sourcing to polite scraping to tombstoning records, it all serves this one single mission. The entire goal is to produce accurate, trustworthy data, because that data is the most powerful tool we have to fight for meaningful, lasting change.
So, as we wrap this up, this is the question I really want to leave you with. We've just walked through a masterclass in building thoughtful, resilient, and deeply ethical data systems for criminal justice reform. But what if we took this exact same blueprint and applied it to other massive social challenges? What about public health, or education, or housing insecurity? What could we build then?